So hello guys, I welcome you all to the Gettobyte channel once again. I hope you all are doing well and working good. So in the last couple of videos of my YouTube channel, I have started with RTOS and I have choose the free RTOS as a beginner to start with it and told you that how I am going to proceed with free RTOS. First of all, creating with the task, how to create tasks, starting with tasks, understanding how task works in free RTOS, and made some two to three application tasks in the FreeRTOS basic application tasks, so as to understand that how do we create multiple threads, multiple processes, run multiple processes in FreeRTOS. And I have used the STM32 and CubeID for this series for starting with the RTOS. And I have also uploaded the blogs on my Gettobyte channel, Gettobyte website. So what is a real-time operating system starting with RTOS. The blog is continuously still I am editing, so it is still in the making. But you can definitely refer it for getting with it, for getting the overview about it. Okay. Now in today's video is a topic which is going to be slightly different from RTOS, but I have got that problem encountered while I was running multiple tasks in RTOS. I am going to tell you the topic of the video will be how to debug HardFault handlers in bare metal system or in RTOS. So let me tell you the backstory of it, that what I am doing and how do I how I am generating the HardFault handler. Okay, so now let's start the video. So guys, before proceeding further, it is important that I just tell you a small overview or tell you a bit about what is HardFault in our Cortex processors, ARM Cortex processors. So like I'm not going to be in very much theoretical detail of this. You can get easily that thing from the internet. There are multiple resources for it, but I'm just going to tell you a small overview about it. That HardFault is a kind of an exception. Now, in ARM terminology, you will see that there are two terms, exceptions and interrupts, which are used very closely with each other. So, first point which comes in your question mind is that what is exception and what is interrupt, what is difference between these two. So, you can consider that interrupts are the external events that encounter our that will halt our processor. Okay, and exceptions are the internal events that will halt our processor. Internal events kind of like if there is some memory fault, if there is some instruction fault that is being executed, if there is something kind like okay, if there is some bus fault in it, that memory gets corrupted. Okay, so these are the processor internal errors which need to be raised and for which processor has to be stopped. So these comes in the exceptions. There are also some exceptions specifically for our operating system frameworks when we are using RTOS. So in that case also there are some internal errors or internal events for which our processor gets specifically stopped. So at that case we name those events as exceptions. Now interrupts are the all those interrupts which are externally, that is all are peripheral interrupts, UART, I2C, SPI, interrupts of like external interrupt, GPIO, PIN, CAN, lane, all these interrupts. So which are like external to our processor. Okay, our microcontroller subsystem. So those are termed as interrupts, and all our internal events will be termed as exceptions. Now, one of the event in this is hard fault. Now, hard fault is an exception, that is, it is will be raised is an exception that occurs because of an error in processing of another exception. That is, if we are processing some another exception and that exception cannot be processed, then hard fault handler will be raised, or because an exception cannot be managed by any other exception mechanism. So like if there is any other exception that is not being defined in the scope of the already given exceptions, or if there is an error and we are executing some ongoing exception, then in that case hard fault handler would be raised. Okay, so I hope you got in clarity like what is exception, what is interrupts, and what are hardfall, and when they are get invoked. When they are invoked, they will be invoked if there is some exception, that if there is some error in processing of an exception, or if there is an event that is not in the scope of any other exception. Okay, so at that point our hardfall handler will be invoked. Now, so like this is what I have to tell you mainly. Okay, so this is my FreeRTOS project. Like in my previous video, I have created two tasks for GPIO and UART. So this is a project which I have created for my creating three tasks. Okay, one task is doing like there are threads. One thread is for like normal GPIO blinking, UART printing on the terminal screen, and third task I have created for interfacing my W25 SPI flash memory, and I am writing the data on it and then reading the data on it from it. So this is the third task that I have created. You can also create it from easily configuring it as I have done in my previous video. So you can refer it from above. And for W25Q SPI flash memory, its driver and its API and its register level coding, that all I have done. For that also you can refer the above video in the notification section, from the notification section. Now the thing is that when I have created the task 3, and in it I am calling the W25Q APIs for erasing the sector of my W25 memory, writing data and reading the data. So now there is a thing which I am using, the SPI handle is being used in my main.c also for initializing my SPI peripheral. Okay, and this one, so in this my SPI is being used in main.c also, and in my driver also, so that I can use the SPI handle for transmitting and receiving the data on W25Q. So at first when I was doing, I have declared this variable extern like HSPI as a static variable. Now what does static do? What I was thinking, that my handle will be only used in this file, so static will make this variable to local, private to this API, to this file only. So that is what I was thinking, and your project will be uploaded. So let me just show you when I declare it as a static. Now what will happen? So let's just debug it. Okay. Okay, so now if I start my program, like it will start running. So you will see it would be invoked the hardfall handler on STM32 ITC, and your program will be stopped. And now then I started thinking, why is this hardfall handler getting? And I was not able to properly understand the stack frame, that what does it mean, that where exactly is my code failing. So now like there is a one thing in our HTML2 cube ID, there is a show view. Okay, and there is a this thing, fault analyzer. So what does fault analyzer do? Fault analyzer is for exceptions only, that will tell you that where exactly and by what reasons your exception is being invoked. So like it shows, fault analyzer shows hard fault detected, and then as I have told you that hard fault is being raised when there is an error in processing the any other exception, or when there is an exception that is not in the scope of any other exception. So it shows that hard fault details, it is being triggered because of bus memory management or usage fault. Okay, and in bus fault details it says improvised data access violation. So what does these two things means? That hard fault is being invoked because of bus memory fault, that is my this thing, bus fault is being invoked. Now why does bus fault exception is being raised? That occurs because of a memory related fault for an instruction of data memory transaction, that when we are handling some data memory, and if there is an error, if there is an issue, memory being corrupted when we are handling the memory for it, okay, then the bus fault will be invoked. Basically when your memory is corrupted or your unassigned unresolved memories are being used, so then it bus fault will be triggered. So by these two things you will get to know, okay, my hard fault is being arising because of a memory fault. There is something related to the memory corruption in my code. Then if you slide on this, you will see the details. So in this you will see the value of the PC. Okay, PC is the program counter. That is, it will tell you what is the location at which your hard-fork handler is being invoked. So now, if you, because of which hard-fork handler is being getting arise. So now in the disassembly code, okay, let me just open my disassembly code from here. Okay, so disassembly is like a map file of your thing where it will tell you that at what address your what function is being there and those things. So now from the fault analyzer, you take the address which is being shown at your program counter and then just search over it. So my address is 8001A, or also like as you can see when I have double clicked on it in the fault analyzer at this memory location, so it will directly make you go to the what exact location at which your program gets corrupted, your memory fault is being invoked. Okay, so now if you will see, so now you will get an idea, okay, there is something in relation because of which my SPI receive function inside the HL SPI receive function, my hardful handler is being invoked. So now if you will go to your main.c code and you just trace it back, okay, so I am using SPI in my task 3, so necessary it would be sure that in my task 3 only your hardful handler will be there. And now if you will go to its first function read ID, so you will see there are two functions in it which I am sending, SPI send and SPI receive. Only out of these two functions my SPI handle or SPI HL APIs will be called. Now you can see that my function is HL SPI receive at the point which is when invoked. So SPI send code is this one and SPI receive code is this one. So it is pretty much sure that okay, when we are doing transaction at SPI, when we are communicating at SPI peripheral, then because of some issue my this hardware handler is being invoked. So then what I think, okay, let me just check the address of my HSPI SPI handle when I am calling for this HSPI handle from the W25 queue, and when I am calling HSPI at the point of SPI initialization. Okay, why so? Because my HSPI is my reference for SPI peripheral. So my HSPI address should be same at main.c also and at W25Q J.C also. Okay, so then how did I so get to this conclusion? Because my memory fault is being arising at HL SPI receive function, and my HL SPI receive function is being called from W25Q. And so I just thought, okay, my SPI handle should be same at main.c also and at this location also. So then what I have done, I made the two breakpoints. One at the point of SPI initialization, that is at this location, so that I can get into the SPI initialization function. And one breakpoint I have made on the task 3 just at the starting of W25Q read ID. Okay, so now let's just debug the code again with these two breakpoints. But like what is now my thinking is, okay, I'm getting hardware handler, then I will first check my what is the location of my program counter, that I got to know from fault analyzer. Even if you are not using cube ID or you don't want to use fault analyzer, you can just check the value of program counter and locate that address at the map file. Okay, and from the map file you will get to know at what exact location of your code your program is being getting corrupted, and from that on you can you can now start analyzing the code. Okay, why this thing can be there, what is my addresses of the variables over this location, what is the address of my functions over this API and this thing. So now my first API would be invoked at SPI initialization. Okay, now I will just get inside this function. Okay, and I will see the live variables made the value of my, okay, so you can see my HSPI and its value is 2001560. So when I am calling SPI initialization, that is the main function at which my address of SPI HSPI reference will be given to SPI peripheral, and that address is 200001560. Okay, now just remember this thing. Now we will again resume our code. Okay, and it will be stopped at read ID starting of my task 3. Now if I step into it, and then if I step into it, okay, and SPI send, okay, and now HSPI transmit, again here my SPI this thing would be used, and now you can see my HSPI address is 200034C. So my address is different when I am initializing the SPI peripheral for HSPI reference, and it is different when I am transmitting or receiving the SPI, because of which HSPI memory fault gets erased, get raised. Okay, and because of this my for handler is being raised. Even if you want to now just check, and like this is a SPI transmit function. Okay, so if you want to check at SPI receive where our main disassembly code shows, okay, at this location only. Okay, HSPI receive function. Okay, so yeah, HLSPI receive, and if you step into it, then also at this location you will see your HSPI address is 200034C, which is different from the SPI initialize, which is 2000158 1F8, and but it is same as SPI receive and SPI transmit, because I have declared my HSPI variable as static. It is not being referenced, its reference is only restricted to this file. It is not referenced from any other file, and this is the error which I am doing. Why? Because my HSPI is being using in main.c also, and in w25.c also, and my HSPI main addressing, it is being main, its value is being assigned at main.c, so its value has to be inherited from main.c code only. So that's how I got to know that why my hard for handler is being invoked, and I got to know, okay, my this variable is corrupting my memory. So then what I have done, I have just changed my variable from static to external. Okay, and now again terminate and relaunch our code. Okay, so if you will go to the run and you will just listen, so skip all breakpoints. I am at this point not halting at any breakpoint, so as to show you that now my code will run efficiently. Now if I run this thing, you can see no, and not any hard for handler is being raised, and all my 3 tasks will be executing. So you can see at the task list that all your 4 tasks are being shown here: task 1, task 2, task 3, and idle task, and your task 2 is being running, at which your stack is also showing. So this shows like your code is running perfectly. But now, like as I have shown you, okay, so now let's just pause at this thing. Okay, now let's just take the address of my HSPI handle. So now I have clicked on the skip all transformers and all my let's just relaunch the code, and now my code will be stopped at all breakpoints. So now we are going to compare the value of HSPI when we have used the external variable. Okay, at the W25Q APIs, when your HSPI is used at W25Q.c file, and when main.c file. So let's just run our code, and it would be stopped at first this thing, SPI initialization, and you will see your HSPI address is 1508 2000150. Okay, remember this thing. And now let's just resume our code. Okay, and it will be stopped at over here, W25Q read ID. Okay, let's get into this code, and okay, send again, and then SPI transmit, and then okay, let's just directly see at the receive. I incidentally step over it. So now if you will see, your HSPI address is same as SPI initialization, 2000150. So now it gets the memory reference. Okay, my reference is same for SPI1 peripheral at main.c also in a W25Q, and your no such memory fault has come, thus your not any hard handler is being raised. So that's how you can debug your hard handler, and you can analyze it. Like at first you just have to first find out at what exact memory location your hard handler is being invoked. Then you have to analyze your code. Okay, what I am doing at this code, why, what might be the reason for memory fault? Is there some variable being declared privately and I'm using it in a global way? because of which there is some error, some memory fault is being coming, or those things. And that's how you can solve your hard for handlers. You can get to know that what is the reason for it, and you can solve for it. I have not written any hard for handler. There is also like some ways for, like, you write your some code in hard for handler when it gets invoked, and you can see it and you can get over it. So, like, I hope you get to know how to solve the hard for handler in RTOS things. Okay, because from a stack frame, we directly can't get to know if an RTOS, your which task is being executed and those things. So you have to correlate that thing with the disassembly code and with your addresses, that where exactly of it is being erasing, and then mapping it to map file, seeing other options and all those things. So this is the one problem that I have raised, and I hope you get to know from this video something. So let's just like in the next upcoming video, I would be more uploading videos on the FreeRTOS. This is the problem that I encountered when I was creating 3 tasks in RTOS. So thus I thought that okay, this might be the important video, and users can get to know how to solve hard for exceptions and some get to know things about it. So yeah, like that's it for this video. I hope you like it, and I hope you get to know some valuable information from this video. I will be also making a blog on this particular to this blog also. So like, but my blog speed is relatively slow as compared to my videos. So like, okay, so that's it for this video. See you in the next video. That's it. Tata, bye bye. So that's it for now. Like the video, subscribe the channel, and press the bell icon to get notified for new videos, and share it with your friends.